When we marvel at images from space missions, one striking absence stands out: the stars. Despite the vastness of the cosmos, these celestial bodies seem to vanish in photographs taken by astronauts. This phenomenon has sparked curiosity and even conspiracy theories, but the explanation lies in the interplay of light, technology, and human perception. The absence of stars in Apollo mission photos has fueled claims that the moon landings were staged. Critics argue that recreating the starry sky in a studio would have been too complex. However, the real reason is far more scientific and rooted in the physics of photography. The key to understanding the missing stars lies in exposure time. Space cameras are optimized to capture bright objects like the lunar surface or astronauts, requiring short exposure times. Stars, being faint, are overshadowed and rendered invisible in such settings. In space, the contrast between bright and dark objects is extreme. To avoid overexposing the foreground, e.g. the moon or astronauts, cameras are set to short exposures, which inadvertently hide the stars in the background. On Earth, our atmosphere scatters light, making stars appear brighter and more numerous. In space, without an atmosphere, stars appear as tiny, faint dots. This lack of scattering reduces their visibility, especially against bright foregrounds. Astronauts like Bruce McCandless, who performed the first untethered spacewalk, describe space as anything but serene. The environment is filled with challenges, from space debris to the constant chatter of mission control, making it a far cry from the tranquil void we imagine. Photos of astronauts floating in space often evoke a sense of isolation. However, these images are carefully composed to highlight the subject, leaving the vast, starless expanse of space as a backdrop. This artistic choice contributes to the illusion of emptiness. In space, light behaves differently. Without an atmosphere to scatter it, light travels in straight lines, making stars appear as pinpoint sources. This lack of diffusion makes them harder to capture in photographs, unless the exposure is specifically adjusted. The Apollo 11 mission photos are a prime example of this phenomenon. The cameras were set to capture the lunar surface and astronauts, not the stars. As a result, the starry backdrop was sacrificed for clarity in the foreground. Solar radiation in space creates a bright environment that outshines the stars. This effect is similar to how a streetlight on Earth can drown out the night sky. In space, the sun's overwhelming brightness further diminishes the visibility of stars. Astronauts often report difficulty seeing stars with the naked eye in space. The lack of an atmosphere means there's no light scattering to amplify starlight, making stars appear fainter than they do from Earth. Long-term exposure to microgravity can affect astronauts' vision, a condition known as visual impairment and intracranial pressure, VIP syndrome. This further complicates their ability to perceive stars and other celestial objects. Modern space cameras are designed with advanced optics and adjustable exposure settings. These features allow them to capture both bright and faint objects, though the primary focus remains on mission-critical targets. NASA's New Horizons probe exemplifies the advancements in space photography. Its cameras can adjust exposure times from milliseconds to seconds, enabling it to capture detailed images of distant objects like Pluto and the Kuiper Belt. Capturing images in the outer solar system, where sunlight is weak, requires long exposure times and highly sensitive cameras. The Voyager 2 mission faced challenges when imaging Neptune's moon Proteus, highlighting the limitations of early space photography. Space photography is a delicate balance of art and science. Engineers and scientists must predict lighting conditions and design cameras accordingly, ensuring they can capture the intended subjects without compromising image quality. Many space images undergo post-processing to enhance details and correct distortions. This step is crucial for bringing out faint objects like stars, which might otherwise be lost in the raw data. Unlike mission-specific cameras, the Hubble Space Telescope is designed to capture the cosmos in all its glory. Its long exposure times and sensitive instruments reveal the true splendor of the starry sky, free from the constraints of planetary photography. Advancements in camera technology and AI-driven image processing promise to revolutionize space photography. Future missions will likely capture even more detailed and awe-inspiring images, bridging the gap between scientific exploration and artistic expression. The vast, starless void of space can have a profound psychological impact on astronauts. The absence of familiar celestial landmarks can evoke feelings of isolation and insignificance, underscoring the need for mental health support during missions. Space photos, whether star-filled or not, hold immense cultural significance. They inspire awe, fuel scientific curiosity, and remind us of our place in the universe. The absence of stars in some images only adds to their mystique and allure. Public perception of space exploration is often shaped by images. The absence of stars in some photos has led to misconceptions, highlighting the need for clear communication about the science behind space photography. Space photography is a unique blend of science and art. While scientists focus on accuracy and detail, artists and communicators strive to convey the beauty and wonder of the cosmos, creating images that resonate with people worldwide. Despite our advancements, the cosmos remains a source of mystery and wonder. The absence of stars in some space photos serves as a reminder of the challenges we face in exploring and understanding the universe. While stars may be absent from some space photos, their invisibility is a testament to the complexity of space photography. It reminds us that the universe is full of wonders, both seen and unseen, waiting to be discovered and understood.